If you are someone who wants to learn dynamic sliding window technique, or if you are someone who wants to learn how to significantly reduce the time complexity of an algorithm, then this video is for you. In this video, I am going to explain dynamic sliding window technique in detail. So please watch this video till the end. So let's get started. Alright guys, let's begin this video with this problem. And the problem says, find subarray with given sum and there is no negative element in the array. Now you might be thinking, why am I talking about this problem? I was supposed to explain dynamic sliding window technique, right? So guys, let me tell you. We are going to use this problem throughout the video to understand the concept of dynamic sliding window technique. So clear? Now moving back to the problem. Here the input is given as 1, 4, 20, 3, 10 and 5 and the sum is given as 33. And our task is to find the subarray whose sum of elements gives the sum exactly equal to 33. Okay? As you can see that in given array, there is one subarray 23 and 10 whose sum of elements is equal to 33. That is why the output of this array is true. Let's say if there is no subarray with the given sum, then the output should be false. Okay? So far, so clear. Now guys, before we move on, let's do some observations. So the first observation is, there is no negative elements in the array. This means we are always going to get numbers that is equal to 0 or greater than equal to 0. This is our first observation. Second observation is the sum is given as 33. And third observation is we have to find the subarray. Okay? And the fourth observation is the size of subarray is not defined. So guys, this is the critical point. You have to give 100% attention on this point. So if the size of subarray is not defined, then obviously we have to find the size of the subarray, right? And in previous video, we have learned that the subarray is equal to k consecutive elements and it is equal to the window size. Now here, for those guys who do not know about window, I have discussed about window and fixed size sliding window in previous video. If you have not watched that previous video, then I highly recommend to watch that previous video first and then come back here and continue watching this video. Okay, moving back to the problem. So here the value of k could be 1, 2 and 3, right? Because subarray could be of one element, it could be of two elements or it could be of three elements. So long story short, we have to find a window whose sum of elements gives sum that is equal to 33. That's it guys. This is what the problem is asking. So now guys, before we directly jump to dynamic sliding window technique, let me show you the basic and the minimal approach to solve this problem. So let's see it how we do it. So this is the given array 1, 4, 23, 10 and 5 and the sum is given as 33. Now what do we have to do here? We have to find all the possible subarrays beginning with current element, and current element could be 1, 4, 23 and 10. So first of all, to pick one number at a time, we need to run a loop from 0 to n minus 1. So this is what we are doing here. So after picking one number, then we have to find all the subarrays beginning with that number. So to do that, we are again running a loop, inner loop from I to n minus 1. So let's say the value of I is 0 and the value present at index 0 is 1. Okay? So how many times inner loop is going to run? From 0 to 5, right? To find all the possible subarrays beginning with 1. Okay? So all the possible subarrays beginning with 1 are listed here. Okay? And the sum is also listed here. 1, 5, 25, 27, 37, 42. And you can see that there is no sum that is equal to the desired sum. That is 33. So what we do? So we simply move to next element. Next element is 4. Okay? So if you consider 4 also, you will not find any subarray whose sum is equal to 33. So we again move to next element, that is 20. Now here in case of 20, we somehow find a subarray whose sum is equal to 33. So guys, this is the point where we need to stop and return true to inform that we found an array and subarray whose sum is equal to desired sum. That's it guys. We simply have to run two loops in this approach to find whether this array contains any subarray whose sum is equal to 33 or not. Okay, so this is the simple approach to solve this problem. Now, the important part is how much time and the space complexity it requires to solve this problem. So let's talk about the worst case, because generally in asymptotic analysis we care about worst case scenarios only, when n tends to infinity or when n becomes larger and larger, right? So we can say that in worst case outer loop runs n times and inner loop runs n times, right? As these loops are nested loops, so we can say that the overall time complexity of this approach is going to be big of n square, right? And we are not using any extra space other than few variables for running a loop. So we can say that this approach is taking constant space. So guys, overall this approach is taking big of n square time complexity and constant space to solve this problem. So I hope everything is clear to you so far. Now here comes the interesting part of this video. In this part we are going to learn dynamic sliding window technique. Okay, for those who do not know sliding window technique, just check out the previous video and learn everything about sliding window technique in that video and come back here. Okay, so we know the meaning of sliding window technique, but what is meant by dynamic here? Now here dynamic refers to the dynamic size of the window. In previous video the window size was fixed, but in this technique the window size is variable. This means either we can extend the window or we can shrink the window. Like this, let me show you. Currently the window size is 2, so we can also extend the window. So we can also extend the window or we can shrink the window like this. So this is what the meaning of dynamic is. So here also we are going to use the sliding window technique, but with the dynamic window size. This is what the dynamic sliding window technique means. Okay, moving forward. So far we saw the brute force approach to solve this problem, and we understood that what is meant by dynamic sliding window. Okay, so now let's use the technique, dynamic sliding window technique, to solve this problem. So we are given an array and we are given a sum. Okay, and our task is to find all the subarrays using dynamic window. Okay, so the question over here is how to maintain window, right? So to maintain window we simply have to use two pointers. And the name of two pointers are S and E. S stands for starting and E stands for ending. So we use these two pointers to maintain the window size, correct? So guys, what do we do in this approach? We simply set the value of S to 0 and E to 0. This means the window size is 1, okay? Because one element is also a subarray in itself. So first we are considering the first element that is equal to 1. And we check that 1 is less than sum or not. This time 1 is less than sum. So in this case, we extend the size of this window to 2. Okay, you can see that the value of E becomes 1 and the value of S is 0. So the window size is from 0 to 1. Again we find the sum of these two elements. 4 plus 1 is 5. And we check if 5 is less than or greater than sum. This time 5 is less than sum. So what do we do in this case? We simply again extend the size of window. Now the window size becomes 3. It includes 0, 1 and 2. Again we are going to calculate the sum of these three elements. 1 plus 4 plus 20. It equals to 25, that is again smaller than sum. Although we are going closer than sum, but still we are not yet done. So again we are going to extend the size of window to 3. Now we have 4 elements in this window, 1, 4, 20 and 3. And the sum of 1, 4, 20 and 3 is 28. But 28 is also less than sum. Now what do we do here? Again we have to extend the size of window. So we increment the size of window to 4. Okay. So after extending the window size, we get 1, 4, 20, 3, 10 in this window. And after computing the sum of all these elements, we get 38. This time 38 is greater than sum. And what was the value of sum? The value of sum is 33 and 38 is greater than sum. So what does it mean? This means when 10 was not added to the subarray, the value of sum was 28. Correct? And as soon as we add 10 to this subarray, the value becomes greater than sum. So we can conclude that there is no subarray that begins with 1 that gives us sum that is equal to desired sum. We can conclude that, right? And this is clear from these two steps, that before we added 10, this sum was 28, and as soon as we add 10, the sum becomes greater than 38. So in that case, what we do, we simply remove 1. And how we are going to remove 1? We simply shrink the window size by 1. Okay, like this. Let me show you. And there we go. Now let's find the sum of these elements. 4 plus 20 plus 3 plus 10. We get 37. And now this is greater than sum. Again we found a number. Again we found a sum that is greater than sum. Okay. So previously we simply remove the 1. Now what to do? Again we are getting sum that is greater than desired sum. So in this case also, you can observe that when 10 was not added to the subarray, the sum was smaller than sum. And here, after adding 10, the sum is greater than sum. So this means that again we have one element that is making this sum greater than desired sum. Okay, this is the first reason. And second reason is that we are traversing this array from left to right, right? And our desired result is 33, then obviously we have to remove the previous element to get the desired element, right? We don't have to remove the element from right because we are already traversing from left to right, correct? And already the sum that we are trying to find is the sum of subarray. So this means there is no subarray that is beginning with 1 that gives a sum that is equal to 33, and that is also no subarray that begins with 4 that gives sum as equal to 33, right? This is the conclusion. This means there is some subarray that is beyond the 4, correct? So that is why we are going to again shrink the window size by 1, okay, like this here, and there we go. And again we are going to calculate the sum of these elements, 20 plus 3 plus 10. Now this time you can see that we finally got 33, and this 33 is exactly equal to the sum. So this is the point where we need to stop and return true. This means we have successfully found a subarray whose sum of elements is exactly equal to 33. Okay guys? So guys, you can see here that although we are finding this subarray only, but we are finding subarrays using 2 pointers and by using window size, and more precisely dynamic window size, right? So this is how dynamic sliding window help us to solve this type of coding problems. So the idea of dynamic window size is pretty simple. We have to maintain a variable size window to find all the possible subarrays, and then as soon as we find sum that is smaller than desired sum, we extend the window size. And if we found a sum that is greater than desired sum, then we shrink the window. This is the simple idea, isn't it? So I hope the idea is clear to you. Now let's move on and see the implementation of this approach. So here we have a function subarray given sum, and this function is taking array as input and the desired sum as input. Okay. In first step, we are initializing s equal to 0 and e is equal to 0, and these two variables are the pointer to the window. And then we are initializing current sum is equal to 0, and then we are running a loop from 0 to less than n for all the elements, right? To consider all the elements. And inside this loop, we are finding sum of all the elements one by one, beginning with current element. And inside this loop, we are finding all the subarrays beginning with the element and finding sum of all the subarrays. And after finding sum, we are checking here that if the current sum is equal to sum or not. If we found the current sum that is equal to sum, then we are simply returning true. Else we are eventually returning false. And inside of this for loop, we are running while loop. And why are we running this while loop? Because if we found that current sum is greater than sum, then we are shrinking the window size by 1 in each step. And then we are subtracting the unwanted element from the current sum. This is what we are doing in this for loop, while loop. So this is what we are doing in for loop and while loop. In for loop, we are taking one number at a time to find all the possible subarrays beginning with that number and then simply adding all the number to the current sum to find the sum of the subarray. And in case we found that the current sum is greater than sum, then we shrink the window size and subtract that number from the current sum. And in the last, we are checking if current sum is equal to sum, then we are eventually returning true, else we are returning false. Okay, so far so clear. Now let's deep dive into this function and see how this function works. So we are given an array. 1, 4, 20, 30, 10 and 5 and sum is equal to 33. We run this program and our for loop begins. In first iteration, the value of I is 0. Okay, and the value of starting index of window and ending index of window is also 0. So in the first loop, the value of current sum is equal to 1. Okay, because of this statement, right? Current sum is equal to ARR of I. So first it's going to add 1 to the current sum because at position 0 we have 1, correct? 1 is less than sum, so we extend the window. In second iteration, the value of S becomes 1, value of E becomes 1. So 1 plus 4 is equal to 5, that is also less than desired sum. Again we extend the window. In next iteration, the value of S is 0, value of E is 2. So the sum of 0, 1, 2 is 25, that is again less than sum. In next iteration, the value of S becomes 0 and E becomes 3 because we extended the window here. So the sum of all the 4 elements from 0 to 3 is 1 plus 4 plus 20 plus 3, that is equal to 28, and this is also less than sum. So we extend the window size by 1. So in next iteration, the value of S becomes 0, E becomes 4. So sum of all the elements from 0 to 4 is 38 and that is greater than sum now. So in this case what we do? We shrink the size of window by 1. So now S becomes 1, E becomes 4 and the sum of elements between 1 to 4 is 37. Again this is greater than sum. So again we have to shrink the size of window. Now S becomes 2, E becomes 4 and the sum of elements between 2 to 4 is 20, 30, 10 and this is exactly 33. So what does it mean? It means there is one array beginning with 2 till 4 that gives sum of elements that is equal to 33 and the output of this input is true. So we found a subarray whose sum of elements is exactly equal to desired sum. So guys, this is how this piece of code is going to run, and I have to say this approach has done an amazing job to solve this problem. Now let's talk about the most important part of this approach, and that is the time and space complexity. Now here you can see that we are running two loops. One is for loop, that is the outer loop, and inside of for loop we have while loop. In for loop we are extending the size of the window, and in while loop we are shrinking the size of the window. So this means in worst case we are going to run these loops n times, right? So guys, you have to carefully look at this loop. Although these are nested loops, but we are not running inner loop for each iteration of outer loop, right? The outer loop only works when we have to extend the window, and inner loop only works when we have to shrink the window. So that is why overall the number of iteration becomes n at max. So this is why the time complexity of this function is going to be big of n. And similarly, we are not using any extra space, so the space complexity remains same as theta of 1. So the overall, this approach took big of n time complexity and theta 1 constant space to solve this problem. So guys, one thing is remaining here. Let's compare this time complexity with the brute force approach. In brute force approach, we saw that the time complexity came out to be big of n square. And you can see that this time complexity is considerably much larger than this time complexity. Here we got n, that is a linear order of growth, and in brute force approach we got n square, that is a quadratic order of growth. So guys, I hope everything is clear to you so far. So guys, now you know how to use dynamic sliding window technique to solve this problem efficiently, and also how this approach can drastically reduce the number of iterations in an algorithm. So guys, this is all from my side. So I hope you learned something valuable out of this video. If you did, then hit the like button, subscribe to this channel and press the bell icon so you never miss any upcoming videos. So thanks for watching. See you in the next one.